Welcome. In this video I'm going to show you how you can analyze a single binary variable using Python and my own created stikpetP library. If you don't want to use my library, I have separate videos on everything I'm going to show you, but I'm building my own library and hope you find it helpful. The library is still in development, so there will be things added in the future hopefully, and this is just to show you how it could work. You will of course need that library. It's actually not on PyPy, so if you want to install it, you can install it straight from my GitHub. Here is the code. I'll leave a link to this Jupyter notebook down below. After you've installed it, you can of course import it just as any other library. I also need some example data to show you how it can be done. So for that I'll use pandas, and then I download a file that's available on my website, low memory false, and this I found so that it can actually load the data file online. And then I of course need a binary variable. Now on this survey people were asked about their gender, and actually only male and female were chosen, so I'm going to be using that one because that makes it a binary field in this situation. To get a quick impression of the data, we can use then the tab frequency function, and then we immediately get a result. And here we see that there were 12 females and 34 people who selected male. You might also see a difference between percent and valid percent. Valid percent is based on the missing values, so there were some people who didn't answer this question. Now we would be interested because there are 62% that indicated to be, 74% that indicated to be male, but is that significantly different from what we might have expected, the 50-50? For that we can use a binomial test, a one sample, and there's a function for that in my library, ts test binomial one sample. We can just feed it the data and then our coding that was used. So up here I made a little array or list with male and female in there, and I can feed that in, and there we have our p-value, or in SPSS called a significance, and name of the test that was actually used. As you might have noticed, there's with equal distance method, which is the default. It doesn't really matter in this case because we're using a 50-50. You can actually change what your expected proportion is with my function, and also how then to calculate the two-sided version. But this is just a quick way of showing you how this test could be done. Then we also need an effect size measure. So in this case it's below the usual threshold of 0.05, so we would say it's significantly different from 50%. We can then use the Cohen's G as an effect size measure. I again use my coding and my data, and there's of course that function for it, and that will simply return Cohen's G. That's actually the difference between 50% and the observed percentage. To qualify this, we can use Cohen's rule of thumb for this. So there's a small function, th for rule of thumb, Cohen G, and there's at the moment only one actually, which is Cohen, but in the future I might find other people's rules of thumb and I will add them in as well. And we can now report it simply that 76% was higher, percentage were male, and 26% was female. We did a one sample binomial test, so we don't actually have a test value, so we only have to report the p-value, which in this case was 0.002, which is actually usually written without the 0 in front of it, so 0.002. Using Cohen's rule of thumb, we can then say that that was a median effect size. In case your data is not based on text, but it has actually everything as a number, I also have the same data, but then where everything is a number, so I'm using the same data set, but now as you can see, instead of male and female, we actually see ones and twos here. I then use a dictionary as well. 1 was female and 2 was males, and we can use that later on. So for example, if we want to see the frequency table rather than just 1 and 2, I can actually enter my dictionary and it will still show the exact same result with female and male. Then the binomial test will of course give the exact same results, and also the g value will again be the same. And then you can again use that rule of thumb. There are some alternative tests available. There is a score or a WALT one sample test, which is sometimes also like a Z test, but then for proportions. We can simply run that. This will have the test statistic, which is a Z value. The P and the N is also the sample size is also there because we might need that later on for an effect size measure. The score test on the numeric data has of course the same results, and for the WALT we can simply use the WALT OS test. Alternative effect sizes are also available. We have Cohen's H, which could be used instead of Cohen G. Again, the same result. And for a rule of thumb, we actually then first need to convert it to a regular Cohen H. So with the ES-convert function, you can convert an effect size measure from one to another. So in this case, I'm going to convert it from a Cohen H for one sample to a regular Cohen H. And then I can use the rules of thumb for Cohen H. And again, that's just based on Cohen. There's also something known as an alternative ratio that can be calculated. That will be done for each category. And as you might notice, that will be the same, of course, if we do the textual data or the numeric data. There is no rule of thumb, unfortunately, so if you find one, let me know. And last but not least, if we'd done a score or a wall test, we could actually use the results of those. The sample size was provided, the Z value, and then we can use what I call the Rosenthal correlation coefficient. It's a simple function. From the top of my head, it's the Z value over the square root of n. And of course, there's a small function for that. If you want to know more about a specific function, you could use the question mark and then simply type in the function. There's quite some detailed docstring here. Unfortunately, it doesn't really generate my math equations. So on my GitHub, you can actually find, or on my website, I will actually put a link with all the nice formatted documentation. But here we can indeed see it was the Z value over the square root of n. Alright, so that's in 7 minutes how you can analyze a binary variable using my stikpetP package. Hope you found this helpful and insightful, and thank you for watching.